Welcome back to my channel. I'm Brian Kafferkey, and this is lesson 4 in a series called Master Databricks and Apache Spark. This lesson we're going to talk about creating an Apache Spark cluster, the open source variety, not a Databricks cluster. Let's jump in. In the lower left hand corner you can see a little image of my book. I won't promote it here, but if you're interested in getting a very comprehensive book on Azure Databricks, 80% of which will apply directly to Apache Spark as well, take a look. It's available on Amazon. So let's take a little closer look at what are we talking about when we talk about an Apache Spark cluster. So we'll discuss what that means, what it is, the options we have for creating a Spark cluster. We'll talk about something called HDInsight, and then we'll actually go through and demonstrate. The bulk of this presentation will be creating a cluster. We'll walk through doing that. What is a cluster? So Apache Spark itself is the project within the Apache Hadoop project, and Spark is an open source big data scale out platform that uses in-memory as much as possible versus something like MapReduce. And it is the underlying service of Databricks. So I've driven this point home a lot. Hopefully you've watched my other videos. But Databricks is, this really nice wrapper with lots of goodies, services, and a user interface, but it's wrapping around Apache Spark. And the reason I'm covering this in a sort of a dual path series is because I know it can be confusing to know where does Databricks end and Spark begin? How do I do the same things I've shown you how to do, for instance, on my book? How do I do the same things if I'm just using good old Apache Spark itself? Maybe on-premise, maybe in the cloud. So that's what Spark is. It's the underlying service. So we're going to cover that in parallel. And it can be installed on-premise, on-prem, what we call in the biz, right? So on-prem, or in the cloud. Now you can even install Spark on your own individual machine, and I considered doing that, but the thing I don't like is then you have lots of things running in the background, and sometimes there's things that are running as services that basically bog down your machine. But if you want to learn Apache Spark and you don't mind installing it, you can always go ahead and install Apache Spark as a standalone mode on your machine. Now I've covered this slide many times in my many videos, but I wanted to kind of highlight that Apache Spark is the engine that covers these services. So it's going to support your data engineering with Spark SQL, machine learning with MLlib, Spark streaming, so streaming applications, high speed, it can handle that, GraphX, so graph API types of queries, batch processing as well as interactive. So a lot of stuff that it can support, and it's all done through the core engine, but it does a lot of different things. And you can use different resource managers, Yarn, Mesos, standalone scheduler, etc. So you have these options. I'm not showing here also, Kubernetes is also supported by Spark. So that's a big trendy thing now, is to use a Kubernetes cluster and all the different containers, and then you can coordinate and create and bring down clusters efficiently and effectively. Spark supports Python, R, Scala, and Java, and SQL, structured query language. In fact, as you can see here, SQL is actually the core of their data engineering Spark engine. Okay, so when you're doing things even in Python, under the covers, it's usually translating that into SQL and then doing the work. And that gives it a lot better performance, and it's been a huge win for Spark overall. And I want to remind you, when I talk about scale out, the idea is that you come in at this driver program level. I need to run a query against a lot of data. The cluster manager is going to be sort of the foreman or the foreperson in front of you that's going to say, okay, I will coordinate this work. I will make sure we get the nodes created, and then we will split out that data into chunks. So we'll say, 50 chunks, and each one of 50 nodes will get a chunk of the data, and they'll run it in parallel. And then all that will be pulled together to the cluster manager, and that will be consolidated and handed back to you and from the driver context, and then you'll be able to get the results. So if each one said how many XYZ exist at some filter, then each one will get a count, and that count will be grand tallied in the cluster manager, handed back to you. And you can see data sources, HDFS is a very common platform to bring data in. Spark itself does not store data. It doesn't need to. It is more popular in recent days to store data using Spark in something called Parquet format, which is good for like reusing, but it's not a requirement. Spark is really like a massive ingest the data in memory and then query it, slice and dice. It's not a platform to store data. It can be used, but it isn't required. So if we want to do Spark, and I had to think about this a lot because I'm going to do a series and I want to say what's the easiest way for me to be able to do this for training. And I considered various options. The first one is I could install it on premise, meaning my own machine. So on my laptop, I could just install Spark. But honestly, it's going to be kind of time consuming. I got to learn about how to do all the configuration, all the settings. I need to shut clusters down, bring them up, and it's only my one machine, right? And I really didn't want a lot of things running in the background. I've got enough stuff, I have SQL Server installations running on my machine already. So I thought, I don't want to do that. All right, what else? Well, a nice feature, I researched this quite a bit because coming from Microsoft, I already knew that there's an option on Azure. But turns out there's options on AWS, Azure, as we said, Google Cloud, IBM Cloud. So if you want to spin up a cluster, a Spark cluster, on any one of these clouds, it's really easy to do. I may have read this wrong. It even looked like IBM might have an option where you can get it for free for a while, or maybe like a low end for learning. Not sure. I may have misread that, but it looked like that. I didn't choose it, even if that's true, mostly because I'm more comfortable using Azure, to be honest. So I went with what I'm comfortable with, and I know what HDInsight can do. So we're going to flip over here. I'm going to use Azure. But as I said, that's just my particular way of using it. One of the challenges, of course, is that each implementation will have their own features and differences. So I can only do so much because I don't know how you will choose to install it. I'm going to try to use something that is fairly generic, and hopefully you'll be able to use it regardless of the platform you're on. But you should be able to just make slight adaptations if you're not using exactly the way I am. So if not, when we get there, you can post comments and I'll help you with that. What is HDInsight? So it's called, HD stands for the Hortonworks distribution of the Apache Spark open source platform, and it is implemented on Azure, and they call it HDInsight. So, however, it doesn't necessarily only mean Spark. The Hadoop platform can contain a number of services, which I've described in my previous videos. So we do have various platform as a service options we need to choose from, and we have several types of clusters that go along with that. And so this shows you, we can do, for instance, the Apache Hadoop, which is really Apache MapReduce now. We can do Spark, we can do Kafka, we can do HBase, something called Hive LLIP, we have Storm, and we have proprietary machine learning services that work with this as well for Azure. Now what we're talking about here is this. We're going to go into HDInsight, we're going to install a Apache Spark cluster. One key difference between something like Databricks versus HDInsight or any Spark cluster that we create is that Databricks has this really cool concept where it can pause a cluster and then you just click a button and say restart it. Technically, I think under the covers, it's still really deleting the whole cluster because it's gone, but you can just click a button and it restores the cluster, and it restores any library dependencies you have on the cluster. Maybe you brought in a lot of extra libraries you want on the cluster nodes, it takes care of that for you. So there are a lot of nice things it does. It'll keep a list of all the clusters you've been working with, and you can just stop and start them however you want. So that's a really nice feature. And with Databricks, it's pretty good about any data you bring up through the user interface, your notebooks, etc., your Hive meta stores that go around describing your data. It automatically will save that because it creates a local blob storage and integrates that in. So it will take care of that for you. With HDInsight, they've done more to improve that. But in general, when you work with a Spark cluster, the cluster itself is self-contained, and if you were putting things on it, it's going to go away. It's not going to stick around. Now we'll see that we can, on Azure for instance, we can put things on blob storage, and it does integrate, fortunately, a blob storage account for us, so we can use that. The reason you want to delete the cluster, though, is that the vast cost, the largest percentage of your cost is typically the compute resources you create, those virtual machines, those containers, etc. Things that are taking CPU and memory in the cloud is going to cost you most of your dollars. The storage is typically small. Even for a lot of my data, a large amount of data, it's typically fairly small. So you want to delete things when you're not using it. And while we go through this series, I will be needing to do that, like bring back my cluster, do some things, and then delete the cluster. So I'm going to show you how to do that, not in this video, but when we get to that next point, I'll walk through, okay, now we need to bring back our cluster, And I'll be using something called Azure Templates as a way to easily bring back a cluster. But we can do it also with PowerShell and the CLI, a bunch of different things. All right, so I'm going to click on this link, portal.azure.com. So once we're in the Azure portal, we want to go to click on Create a Resource. And in the window, where the search window is, we're going to type in HDInsight. And we can see under here, Azure HDInsight. And we're just going to click Create. I'm going to use the default subscription. I'm going to create new here, and I'm going to say RG underscore BPC Spark. And see if that lets me get away with that. Okay. And for my cluster name, I'm just going to call it BPC Spark. Now, the logic behind the naming is whenever I create a resource, I typically recommend, and this is what I do, I create the resource group, which is the container to hold whatever I'm creating, RG underscore, so I know that's a resource group. And then the name, I make sure agrees with the name of the resource I create itself. So this place, in this particular case, I'm calling it BPC Spark, and the resource group is RG underscore BPC Spark, so I know they go together. When I don't want anything related to this anymore, I would delete the resource group. So that will get rid of everything, not just the Spark cluster, if there's anything else. So now I got to select this cluster type, and I'm going to go and select Spark because that's the one we want. I need to give it an admin name. This is going to be what we'll use to log in. And I need to give it a password. And then again. Okay. Everything else looks good. So I can say next, go to storage. And one of the things I want to show you on this screen is that by default, you get a primary type. You get basically an Azure Blob Storage account. And you can see that you have the option of going to Azure Data Lake Storage Gen 1 or Gen 2. We're not going to use those. Those are designed for when you have lots of data. You want to optimize the storage for that kind of for large volumes of data. And Gen 2 is typically the one that you would select today. So we've got a storage account ready. We're good here. We have security and networking. I think we have what we need. I don't think there's anything here we need to do. So I'm just going to go straight to review and create. Okay, it says we need to give an answer here for somewhere. So it's telling me, and this may happen to you, on the configuration, I need to set this down a bit. So let's see if I can get away with 2. It looks like that will let me do it. I don't have the hugest, largest resources made available. You would think perhaps that in Azure it will just let you use as much as you want as long as you'll pay for it, but that's actually not what happens. There's a video I talked about earlier, but one I have that talks about problems you can have creating a Databricks cluster, because by default your subscription is actually limited in what it can do. The trial subscription is particularly limited, so I'm using different things, and I have to either ask Microsoft to give me more resources on my license or just lower it to fit our requirements here. So let's hope we can get through this. Okay, yay, we got it. So now we have our cluster ready to go. All I have to do here now is click create, and we're going to get a cluster created. So, okay, so our cluster has been created, and you can see here it's available. It says go to resource. We can also go to the bell where we can see things getting created, and here we can say go to resource or pin to dashboard. So I'm going to say go to resource. You can pin it to your dashboard, and I've done that on other videos. Just means that you'll have a dashboard, you can go back and find it later. So let's say, I'll just click here, go to resource. And this gives us kind of a typical thing within Azure when we create resources, like even the Databricks workspace. We have the overview blade, which things for the resource group, documentation links, etc. A lot of basic things, what region we're in. It provides the basic sort of starting point and sometimes launching point for our resource. We have activity logs, access controllers so we can add people in to share with them, typically for the resource, things like that. We can see things around the cluster size, quota limits, all kinds of stuff here. We can see our storage account here. So you can see we do have a storage account. And we go in there, we can see we have containers. So this really gets into understanding how blob storage is, but when you get a storage account, containers are typically used to like folders that will hold things like files, and that's called blob storage. And within here we can see we now have this container, this folder. If we go into it, we can see that part of a cluster has installed a lot of things for us. And we can see we have samples, examples, etc. that we can work with. So we've got a lot of different things here. Let's go back to the top of this. And I did notice it's a little tricky once you go down to blob storage getting back to where you came from. But here we are now on the cluster. What I wanted to just quickly demonstrate is we have a couple of ways we can use the cluster right away, which is nice. We have the ability to use something called Zeppelin notebooks or Jupyter Notebook. Now, I've done a lot of things with Jupyter Notebook, and that's an option, or I can use Zeppelin. So let's take a look at how to use a Zeppelin notebook. So I'll go in from the overview pane, as we can see. I'm going to use a Zeppelin notebook. And if I go in here, you can see help and documentation, but I'm going to go to job. And here, from here we can get some demo notebooks. We can get a look at things. Now, one of the things you'll notice about Zeppelin notebooks is as you start to use them more, they become very similar to, or you seem to notice similarities with Databricks notebooks. So up here we have a sort of overall notebook navigation. And then within each cell, you can see this little bar up here. And this will run the cell. And this is to sort of edit a cell if I click on it. And you notice that it has a %MD. It tells it that the kernel to use is Markdown, which is documentation cells. Exactly the same thing you would do in a Databricks notebook at the top. The Zeppelin notebooks do support multiple kernels in the same notebook, which is handy. And it's using the percent identifier to basically say which one you want to use. Okay, so let's kind of scroll down here for a minute. And a lot of this particular sample notebook is resilient distributed data sets, but I want to show you something more like what we'd probably really use nowadays, because RDDs are not as common anymore in terms of use. So you can see at the top again, the %libby2 PySpark identifying that we're using Python in this cell and importing libraries. And we're not going to get into the code right now. We'll learn more about that later. That's fine. This bottom line here is the real key thing, because it's creating a DF, a data frame. So it's creating a Spark data frame here, and that's what the end result will be. To run this cell, I just click this, and we will learn more about using Zeppelin notebooks as we move forward into it. And I'm learning a fair amount as well, because I particularly adopted the Zeppelin notebook so I could do the parallel material on Spark. Okay, so let's do this right here, and it's already, you can notice I've already run this to test it, but I'll just run the cell to prove it runs. And the ultimate thing it does is here is it's displaying the data frame, so it's just doing this display. Again, not a lot here, I just want to give you the feel of things, but through using a Zeppelin notebook, which is automatically provided with our HDInsight Spark cluster, we're good to go. We can start right in and start doing work. So this is great. And you'll also notice if we go to the top of our notebook and click on our config, these are the different kernels that are installed, and we can configure these. So you can see at the top that it always says Libby, but it's saying SQL, PySpark, PySpark 3, Spark R, shared, Markdown, SH, Angular. So a lot of different kernels are automatically installed for us. So we can just say save, and that now becomes our notebook kernel. So got a lot of power here. So I hope that explained, we covered how to create your own HDInsight cluster, Spark cluster, and you can do that on any cloud you want, however you want. But if you want to follow along and be able to do the code samples I'll be doing exactly, then you'll want to use HDInsight and use the Zeppelin notebook so that everything lines up correctly. We started out this presentation talking about what is an Apache Spark cluster, and we learned that it's the open source Apache Spark project platform, which is part of the Apache Hadoop project. And we learned in the previous discussions that Apache Hadoop is this big collection of all kinds of data services. So the Apache Spark, though, is open source, and it is the underlying platform for Databricks. So I would say think about 85% of what Databricks is doing is really being provided by Spark, and then the extra special bells and whistles are being added by Databricks. We saw options for creating a Spark cluster, which includes on your laptop, on your own premise environment with many machines, however you want to, or in the cloud. And every major cloud. I mentioned several cloud environments, but AWS, Azure, Google Cloud, and IBM support creating a PaaS version, a platform as a service offering of Spark. So we saw HDInsight. Go to the next one. What is HDInsight? HDInsight is Microsoft Azure's PaaS offering of a number of Apache Hadoop project platforms, one of which is Spark, and that's the one we saw how to implement. So we walked through creating a Spark cluster on HDInsight and how to use it with Zeppelin notebook, but also noticed we could also just as easily have used the Jupyter notebook. Again, I preferred Zeppelin because it comes with sort of more kernels ready and available. All right, so I hope that was useful. I hope it helped you. Put comments below and let me know if this is great, if it's not great, what you're interested in seeing, and share with your friends. Let people know about the channel, and hopefully it's helping people. It's what it's here for. That's it. I'm pulling for you. We're all in this together.